In this video, we're going to explore caching in Spring Boot using a simple example. One thing we want to think about is where is the optimal place to put a cache. And here I have an architecture that we'd often see in a Spring Boot microservices application, where we have some kind of HTML view, and then under that we have an endpoint that's defined in a controller. Under that we have the service layer, which sometimes when you're new to programming, it doesn't make a whole lot of sense what that service layer is for. But in this video, we'll see a good example of why we want a service layer. Underneath that, we'll have a data access object layer. Oftentimes under that, we'll have a CRUD repository or an extension of that interface, and then a persistence mechanism, which may be a database. So the service layer, or the business logic layer, many times will call down upon multiple DAOs. It could just be one, but many times it's aggregating data from multiple DAOs. And we see that there is a bit of heavy lifting after this DAO because it has to go to a persistence layer, which may be on a different physical server, different physical machine, maybe even a different network entirely, so it might involve a network call. That's why we like to do caching. So what we'll often do is we will annotate methods at the service layer, and we will put a cache there. Now, what do we mean by cache? Well, think about what method calls typically are. In a method call, you're typically passing in a parameter and getting an object back, at least in a read method call, in a fetch, or some kind of fetch by ID method call. So think about the joke about what's the definition of insanity. It's doing the same thing over and over again and expecting a different result. So if you pass the same lookup key or the same lookup identifier into a method over and over again, you should get the same result. Does it make sense that we should have to query the persistence mechanism every single time? Probably not. It would probably be a little bit more efficient if we took that result and we put it in some type of collection, and we used the key, the find by ID key, and associated it with that result. So in future calls after the first call, we don't need to go to the persistence layer. Instead, we can simply go to this collection and say, hey, do you have a result for this key? If you do, then I would like to retrieve it. So why do we cache? We cache at that service layer. We could anywhere, but service layer makes a lot of sense. And why do we want to cache? Well, we know it's going to be better performance because we're taking a lot of load off of that persistence mechanism. In addition to that, it's better scaling. When you get to a high transaction volume, you could max out what a database could do in a reasonable amount of time. But with a cache, you're not hitting the database. You're reducing requests, again, in a high transaction volume situation. So because of that, the database is able to serve more users, and that essentially is scaling. Now we can also have distributed caching, where we have caches that live closer to where the user physically is. We're not going to talk about that in this lecture, but we're just going to take a look at a simple example. So we have exception handling. We'll think about how less chance of exception if we have less time we have to go out of our domain. Checked exceptions, the things where we have to wrap a try-catch block, many times in Java that's because we are accessing something that is outside of the JVM, like a file system, like a database, something like that. So service layer, we talked about why we want to do it there, because that's where the DAOs are aggregated. So let's consider some trade-offs. The pros, we know increased performance and scaling, as we just discussed. Less disk I/O, which makes the disk able to serve more people again. And then a scalable database, as we spoke. But, okay, what's the trade-off? Well, naturally, we have to configure the caching for one. The other thing is that the cache is going to store more data in RAM, or in temporary memory, than it would without caching. So essentially, we're doing a trade-off here where we are increasing RAM, and the advantage is we're getting less disk I/O, less hits to the database. But we do want to consider that RAM. Maybe we want to bump up the RAM, or at least the RAM allocation to our application server. This is easy to do in Spring Boot, so easy we'll do it right now. So first of all, on the application class, we need the EnableCaching annotation. And then on the method that we want to cache, we use @Cacheable. And we can use the method parameters as the key, and essentially the return type is the value that gets returned from the cache. So we will, in a future video, we will take a look at a specific implementation of a cache called EHCache. One thing I wanted to call out in this video before we get to the more advanced caching, though, is be careful about debugging. This one caught me one time. Remember, if we apply a cache at the service layer, the very first time we do a lookup, it's going to go down and back up this entire stack. The second time we do a lookup with the same ID, it's going to stop at the service layer and return the result that was cached. The first time I dealt with caching, it was an implementation that somebody else wrote and I was not aware that it was present. And I set a breakpoint in a DAO layer, saw it hit the first time, then I went back and I kept requesting the data over and over again and I could not get the breakpoint to hit. So I tried a different lookup, breakpoint hit, okay great, I got that working. Tried that different lookup one more time, breakpoint didn't hit again. So just be aware that, I guess it sounds obvious in hindsight, but it sure didn't sound obvious at the time. Just be aware that your breakpoints down in the lower area are not going to hit when you're debugging if you have something that is cached. Adding caching is incredibly easy because all we need is an annotation. Actually, 2 annotations. So that will take just a moment. We'll spend a bit more time looking at a demo with the debugger. So first of all, our application class, the one that has the Spring Boot application annotation. Let's give ourselves some space and add a new annotation, EnableCaching. Now let's take a look at our service class and consider a cacheable annotation on top of anything that is a read operation, like a fetch operation. So here we have fetch by ID. So I'll add @cacheable, and we can give it a value by default that represents this item that's being cached or this collection that's being cached. In other words, we want to cache specimens separately from plants. And because this is returning a specimen, let's go ahead and give this cache a name specimen, singular specimen, just like that. Now the cacheable annotation will automatically consider the incoming parameter as a key and the return type is what it is caching. We can specify more details, but by default, if we just specify a name, it's going to figure the rest out for us. Now let's go down to the fetch all method, which is very similar to this fetch by ID method. And we'll go ahead and add a cacheable annotation here as well. The trick is, if we look at this, we say, oh hey, it's returning specimens, just like our fetch by ID. But notice that the return type is actually different. It's returning a list. The list contains specimens, but it is multiple specimens, and there is no key getting passed in. So we need to give this a different ID. Let's call it specimens. We'll just make it plural specimens. Finally, we're fetching plants, which we get from a JSON data source, but this is used in an autocomplete. And per iOS guidelines, if we're using autocomplete data, we should source that data locally. We shouldn't go over the network because people can press keys very quickly, and network round trips tend to be long. Let's go ahead and cache this one. Again, cacheable annotation, and this time we'll call it plants, plural plants, because there are multiple plants. I set breakpoints at the controller, the service, and the DAO level. And because we applied caching at the service level, what I anticipate will happen is the first time I make a get call, it's going to hit all 3 layers of breakpoints. The second time I make a get call, it will only hit the controller. So let's try it out and see. I'll start with my old Postman collection and we'll take a look at the specimen endpoint. We see that several breakpoints are going to hit here, so we have one in the controller. I press F9 to tell it to go. We have one in the service, and we have one in the DAO. And that's going to return to us a series of specimens that we have retrieved from the database. Let me hit send one more time and let's see how many breakpoints hit. Our controller breakpoint hits. I press F9. No other breakpoints hit. So do you see how caching that helped us because we only had to go through all of those calls one time. From then on, it was served by memory. Now, the specimen endpoint without an ID will return all specimens, and we remember we have that in one cache. If we want a specific specimen, we're holding that in a different cache. So let's go ahead and look at that specimen number 7. We look at our breakpoint in the controller, from controller to service, from service to DAO, and then it returns. So it has to populate this cache as well. Let me hit it one more time and think about what's going to happen here because this is the second round trip I've had with this exact same ID. We see it in the controller and then we don't see it again. That works out pretty well, but let me show you something that can be a bit misleading. What if we delete number 7? So we do the delete endpoint, we get back a 200, it has been deleted. We look in the database, we confirm that the plant number 7 is no longer there. What if I do that get call again? What happens now? We hit a breakpoint, the breakpoint stops at the controller, It doesn't go any further than that, so you notice it doesn't actually go down to the database. And what does it do? But it gives us this specimen that was still stored in cache. So is there a way where if we delete something with a delete endpoint that we can empty that item from the cache? Well, sure enough, there is. We simply have to add a bit more to our annotation. So let's do that. And we're going to find a brand new annotation as well. So we return to our service. On the delete method, we'll add a new annotation called CacheEject. And during a CacheEject event, we can either remove everything or remove one thing. We'll start by defining the cached collection where we wish to evict a member. So we'll say value equals specimen. Specimen in quotes, just as we have it up here, so we're referring to this cache. If I wanted to remove everything, I would say all entries equals true, like so. But in this case, I just want to remove one thing. So I will say key equals, and then we have to give the key that's used to store this information. And if we look both at fetch by ID and delete, we see they are both accepting an ID, and that ID represents the unique identifier of this specimen. So we'll just say pound ID. Now, incidentally, it's a good idea if we make these two things look the same, the CacheEject and the Cacheable annotation, if nothing else for a bit of documentation. And the reality is they can look the same because they do have the same attributes, and we can give them the same values. So let's say value equals specimen, key equals, and then in quotes, pound ID once again. Since we've deleted number 7, we'll use number 6 in this instance. So let's go back and do a get operation on 6. Of course, that will toggle a fetch by ID. We have our controller, and as we expect the first time around, we have our service, and then we have our DAO. We come back to Postman, and we have our specimen ID number 6. Let's go ahead and send this one more time. We'll see the breakpoint hit in the controller, and that's the only breakpoint, and it comes back, and once again, it gives us the same value, so we confirm that that is coming from our cache. Let's go ahead and do the delete now. So I hit delete and send. We got our status 200. Now let's go back and do the get one more time. And this time it should be purged from our cache, so we should see multiple breakpoints hit. So I hit send. We see our controller breakpoint. I choose F9. Ah, look at that. We have our service breakpoint. I choose F9. And then finally, we have our fetch breakpoint. I choose F9 again. This is going to give us kind of a funny internal server error because it wasn't sure how to handle that return value. That's okay, we can handle that separately. But nonetheless, what you do see now is that it purged the item from the cache. So the next time we went to get it, it said, hey, I don't have anything associated with this ID number 6, so I'm going to go down and try and fetch it. And that only happened after we purged it. Now, because we're fetching by ID and purging by ID, if I had looked up any other IDs like 5 or 4 or 3 or anything else like that, those would be unaffected. It's only the one with the specific ID that I've indicated in the delete annotation. It's only that one that's going to get purged. Let's go back and just confirm with our database that that delete did happen. And sure enough, we see that row number 6 is gone. So you see, the more we access the cache, the more we're populating the cache. So this has been a look at caching, which is definitely a good idea, especially for enterprise applications today, because many times our applications are serving things like web browsers and mobile applications where we don't know how many devices are going to be accessing our application at any one time. So this is a very efficient and, as you saw, a very fast way to increase the scalability, speed, and performance of your app. I hope this video was helpful, and I look forward to reading your comments. Thank you.